Okay, let's talk about lowest common denominator. Which one was lowest common denominator? 4. The least number into which the denominators of 2 or more irrationals will all divide. Yes. So 4, good. How about binomial? 2, yeah, right across. Binomial. Quotient. The bottom of a fraction. No, that's not bottom, so that's denominator. Oops. 4 is not 4. 5. The result of dividing one quantity by another. Yes. Common factor. An integer that divides into 2 or more other integers. Yes. That would be 7. V is 5. I is 1. If it's after we add it, if it's before you subtract. No. Equivalent rational numbers. 3, right. If we multiply this guy by -7 and this guy by -7, it's equivalent. So 3. And last, factored form, it's when it's in a product, something times something, so that would be 1. This is a 3. Okay? So this is some review of terminology. All right, so let's review how do we multiply fractions. Straight across, multiply straight across. So there's 2 ways we can do this. We first can multiply across and then reduce. So that's one way. So let's go straight across. 15 and 40. So 15 over 40. What will go into both numbers? 5. So I'm going to divide the top and bottom by 5, which equals 15 divided by 5, 3 over 8. Yeah. Okay, the other way is we reduce, then multiply. So you can actually reduce first. So reduce, then multiply. So 2 over 9 times, how do we make 3 into a fraction? 3 over 1. So what we can do here is what can be reduced from numerator to denominator? 3 and 9. It doesn't have to be in the same fraction. So we can reduce 3 over 9. We can divide both of those by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So reducing first. And it doesn't when you multiply, it doesn't have to be in the same ratio to reduce. And now we go straight across. 2 times 1 is 2. 3 times 1, 3. The nice thing about that method, the numbers stay smaller. And sometimes it's hard if the numbers are really big to reduce it after. Well, we're going to get to a point where that's not always going to work for using variables. So we can reduce before. So 3 and 9, we divided both of those by 3. So we divide both by 3. So that 3 divided by 3 is 1. 9 divided by 3 is 3. And then you still go straight across. 2 times 1 is 2. 3 times 1 is 3. Okay, I'll do one more. When we divide, what do we have to do? Flip and switch. Flip and switch to multiplication. So for example, I'm going to show you the reduction way first. A lot simpler. So what can we reduce here? 21 and 7. What can we divide both of those by? Close. 7. 7 divided by 7 is 1. 21 divided by 7 is 3. How about 2 and 4? We can divide both of those by 2. So it has to be 2 numbers, right? You're one on the top, one on the bottom. So it's basically like 2 over 4, you're reducing to 1/2. We can divide both by 2. 1 and 2. And now we go straight across. 1 times 1, 1. 3 times 2, 6. Now you could also multiply first and then reduce, but I wanted to show you this new method because it actually will come in handy later in this unit. This guy, I love these guys. They look worse than they are, right? No? Okay. How would we write this with multiplication? 4/3 So it's divided by 5 over 12. So we'd actually change it to times by 12 over 5 times by the reciprocal. Do you want to go straight across and reduce, or do you want to reduce first? Okay, let's reduce first. Sorry, you lose. What can be reduced? 12 over 3, right? 12 and 3. What can we divide both those by? 3. So divide by 3 is 4. Divide this by 3, it's 1. Anything else? No. So 4 times 4, 16. 1 times 5. Oops. Silly. Yes, 5. Now, if you did go straight across, you'd have to go 4 times 12, which is 48. And then 3 times 5 is 15, and then divide both by 3 again. 16 over 5. Okay. It did fall. You were right, Stacey. Okay, so that's multiplying and dividing. A lot easier than adding and subtracting, right? Because what do we have to have when we're adding and subtracting? Common denominator. Oh, yeah. Good old review. So 2 over 7 and 6 over 7, do they have a common denominator? 7. They both have a common denominator of 7. So when we add, we just add the numerators, keep the same denominator as long as that denominator is the same. So this becomes 2 plus 6, 8 over 7. Okay, to make these guys the same denominator, what would be the lowest common multiple of 3 and 5? 15. So you'd have to multiply 3 by 5. So top and bottom, we're going to multiply by 5 for that fraction. The second fraction, we're going to multiply top and bottom by 3. So this becomes, the first guy, 5 times 1, 5 over 15 plus 3 times 3, 9 over 15. 9 plus 5, 14 over 15. Often, not always. So for example, can we make 5 10? How can we make this a 10 here? Times it by 2. So here's an example where I could just make this guy a 10. We don't have to change him. Because if you made 10 10 and then 5 5 here, you're going to have to reduce your fraction in the end. So you can do that, but then you'll have to reduce. Okay, so this becomes 2 times 4, which is 8 over 10 minus 3 over 10, which gives you 5 over 10, which equals 1/2. We reduce it. What is the lowest common multiple of 4 and 6? The smallest number, the 12. They'll both go into is 12. So how do I make 4 12? Times by 3. Fun stuff, right? It's been a while since you've probably done this. And to make 6 a 12 times by 2. I know, when you haven't done math in a year. Oh, sorry. You should sit in the front if you're not going to wear glasses. Okay, 3 times 5. 15 over 12 minus 10 over 12, which gives us 5 over 12. Okay, so why did we review that? Well, we're going to be adding, subtracting, multiplying, dividing rational expressions this unit. So fractions with variables. And how are we going to be able to divide them? Well, we're going to have to factor. So those two skills are tough skills, but we'll have to review them and solidify them. Remember that when we solve quadratic equations, this is back to grade 11 now. If we have an x squared, we need one side equal to 0, and then we have to factor to solve. So it's usually going to be one of 3 things: GCF, simple trinomial, or difference of squares, what we wrote on the board. We always check for greatest common factor first. Remember the pink crown? I still have it. Yeah. So a GCF is basically saying, is there something that will divide into everybody here? What can go into both of them, or what's in common? Do they have something in common? They both have an x. So how do we pull out the GCF? We divide each by that GCF, and where does it go? On the front, yeah. So we wrote x, and then to figure out what's left over in the brackets, we actually divide. What is x squared divided by x? X, one of the x's cancel, plus, x's are gone, so plus 4 equals 0. So now that it's turned into a product, so here this is an example where we had GCF. GCF. Now that it's turned into a product, basically the theory is if A times B equals 0, what does that mean if A times B equals 0? What do we know about A or B? One of them has to be 0, right? 0 times something equals 0. One of them has to be 0. So we have two things that we're basically figuring out, okay, what would that x be to make this 0? So here's the first. Well, x would have to be 0 for it to be 0. So x equal to 0. And the other one, what would x have to be for this expression right here? Negative 4, because negative 4 plus 4 equals 0. Is that coming back to you? And then find the zeros. Yeah, so you grab your graph and does anyone have that with you today? I'll just pull it up here for you when it opens. There you go. So the other way to find your zeros, yeah, you can actually put in the original. You don't even have to put the factored form in. So x squared plus 4x, but you will have to be able to factor in this unit. You graph it, and we're looking for the zero. So it crosses the 0 at negative 4 and 0. That's the solution. I just typed in the original, x squared plus 4x. There's two ways you can look at it, or second trace 2. Second trace 2. Okay, next guy. Is there a GCF? 4 and 9. No. So the question is this a simple trinomial or is it GCF, or sorry, difference of squares? This is a difference of squares. What makes something a difference of squares? You could square root both of these. Two numbers separated by a minus. It's a binomial. It has to be a binomial. And then both of them perfect squares, and it has to have a minus. Okay? So this is a difference of squares. Oops. Difference of squares.
Wow, that's great.
Did it really? That's awesome. Okay, so what's the square root of 4x squared? 2x. What's the square root of 9? 3. So you're going to have what, and then what happens? One of the signs is plus, one is minus, equals to 0. So how do we see our zeros? Remember the trick here? So for the first one, opposite sign, second over first. There's two ways to solve for it. The other way is you can literally go 2x plus 3 equals 0 and then solve for x. So minus 3, 2x equals negative 3, and then divide by 2. So the shortcut is opposite sign, second over first. So we have a negative 3 over 2, and this one would be positive 3 over 2. So you could also write that as plus or minus 3 over 2. You're thinking about non-permissible values?
Yeah.
We're going to do that tomorrow, starting tomorrow. Yeah, and you start at you do throughout the whole question. All right, see what kind, well, there's a problem here. What's the problem right now if you have a quadratic? Doesn't equal 0, so we have to make one side equal to 0. How do we make one side equal 0? Subtract 6x. Oh, it's so warm in here. Okay, I'm going to turn down the temperature if that's okay. Yep, I'm going to pause it. Do you want to try and factor this simple trinomial while you wait? So, in a simple trinomial, to factor this, we need two numbers that multiply to what? Positive 9 and adds to negative 6. So if we're going to multiply to a positive but add to a negative, both numbers are negative. A negative times a negative would be a positive, and negative plus a negative would be a negative. What are the two numbers? Negative 3 and negative 3. So in factored form, if it's a simple trinomial, what makes something a simple trinomial, by the way? Yeah, just an x squared. There's no coefficient in front of the x squared. Right? If it had 2x squared, then you need first times last. A lot more work, which is decomposition. So x minus, we just put those numbers right into factored form. And so what's our solution? X equals, what would make this a 0? Positive 3 and positive 3. So we only write it once. Right? And you can check your answer. Plug in 3 here, and it should equal 0, the product. Okay, so that's a review of the factoring stuff. Turn over to the next one, and then the last 3 I'll get you to work on. All right. Not that hard, but I can help you if you'd like. Okay, this guy here, 5x over 3 equals 7 over 12. When you have a fraction equal to a fraction, what can we do? I usually discourage this, but we're going to do this a lot this year, actually. Fraction equals, or ratio equals a ratio. How could you solve that? Cross multiply. Okay, so we're going to actually use that here. So we'd have 12 times 5x equals 3 times 7. Whenever we have a fraction equal to a fraction. It doesn't work if you had a fraction equals a fraction plus something. It just has to be two equal ratios. Okay, 12 times 5x, what's that equal to? 60x. What's 3 times 7? 21, and then divide by 60. So x equals 21 over 60. And I think we can reduce that. Uh-oh. Yeah, we can. Yeah, we could divide both by 3. Now, does your calculator help you with these ones? Yes. 7 over 20. How does it help you, Dean? Math, enter, enter. So 21 over 60. Math, enter, enter. Remember that? How could you forget? Okay, I think you should try the next one on your own. Try and solve for x. You were supposed to go a second ago. It's hard. Let's go. Okay, guys, try this one on your own. Start by getting rid of the brackets. Start by getting rid of the brackets. Distributive law. Distributive law. X squared plus 8x, when we bring in the x, you want to keep the x squared positive. Otherwise, you're going to have to, there's a GC, you have to factor out the negative from everybody. Factoring. Okay, so we want to bring everything towards the side of the x squared so that we have a positive x squared and not a negative x squared. Because if it has a negative x squared, it's technically a complex trinomial. So how do we move these? We have to subtract the 3x, and then we're going to subtract the 14 over as well. That will cancel these guys out. So we're left with x squared, 8 minus 3, plus 5, and then we have a minus 14. Okay, now it's a simple trinomial. How do we deal with factoring simple trinomials? Two numbers that multiply to -14 and adds to 5. 7 and -2. Correct. And so we go straight to x plus 7, x minus 2. And so what's our solution? -7 would make this 0 and +2. X equals -7 and +2. Oh, no, we were doing B. Okay, so whenever you're solving quadratics, I guess I choose red. If you're solving a quadratic, you're always making one side equal to 0. Jesse? Shh. One side equal to 0, and then you have to factor when we're solving quadratics. Okay? All right. Now, do you want to try the next 3 on your own, or do you want them together? Or start? Okay. So it's really, this is about adding, subtracting, dividing fractions. That's what these questions are on. They're not. So let's try and draw a picture in this problem when it says a rectangle. 2 rectangles are joined side to side. Each rectangle has a width of 1 1/3 inch. One rectangle is 7/8 of an inch long, and the other is 2 1/4 inches long. What is the exact area of the composite figure? Use a sketch to help you. So first, let's draw it. Composite means more than one shape put together. So let's draw this. We have 2 rectangles side by side. Two beside. Now, what's in common? The width. The width is 1 1/3. Let's change this to, we don't want a mixed fraction, right? 4/3. We don't want the 1 in front. So remember how we do this? 3 times 1 plus 1. So it'll be 4/3. 3 times 1 is 3, plus 1 is 4. 4/3. So they both are 4/3 of an inch width. That's the width. The width. They have great because that's what's the same as their width. One rectangle is 7/8 inches long. So that would be the small one. So that's this portion just right here. And the other rectangle is how much? 9/4. Yeah, 2 times 4 plus 1. 9/4 of an inch. Okay, 3 times 1. So if you have 1 1/3, if you have 1, right? You have 4/3 because 3 times 1 plus 1. Okay. Now, how are we going to get, how do we get area? That's volume. Length times width. So, we need to know, we know its width. Do we know its full length? How do we get its full length? Add them together. So the length is going to be 7/8 plus 9/4. What's wrong with this right now? Common denominator, who are we going to change? 9/4. How are we going to change it? Times the top and bottom by 2 to make him an 8. So it's 7/8 plus 18/8 equals 25/8. So now we know its length. We already know its width is 4/3. Let's find our area. So length is 25/8 times 4/3. Do you want to reduce first? Okay, what can we reduce? 4 and 8 we can divide both by, or even bigger, 4. 4 divided by 4? 1. 8 divided by 4, 2. 25 times 1, 25, and then 2 times 3 is 6. There's our, and that would be inches squared. Is our area. All right, I'm going to leave the other two for you to try. One thing I will say about number 8 is I'll give you the formula. The formula for average speed is total distance divided by total time. Okay, I will also tell you that there's 1,000 meters in 1 kilometer and 60 seconds in 1 minute. Okay, so I'd like you to try those last two, and then I can help you if you need it. All right.